Integrated Math 3, this is the test prep, the final test prep that you're going to be doing on Monday, May the 22nd. So you want to take these problems and practice them. These are the problems that are going to be on your test on Tuesday, May the 23rd. So you'll turn this in on Tuesday, May the 23rd. Okay, let's get started. All right, so number one, you're asked to multiply these. So what you want to do is group like terms. Okay, so 6 times 5 is 30. X to the 4th times x squared is 4 plus 2. X to the 4 plus 2. You add the exponents in this case. And y to the 3rd, y to the 7th is y to the 10th. And that's your final answer. All right, remember you can always slow this down or pause it when you need to and go back and watch something again. Okay, similar type of problem. We're going to group like terms. 30 divided by 5 is 6. X to the 12th, x over x to the 3rd, you subtract. 12 minus 3 is 9. 9 minus 7 is 2. And that's the final answer. All right, so you can do this on your calculator. You can do negative 3 to the 6th. Or if you want, you can simply do it this way. 6 minus 3 is 3, so it's negative 3 to the 3rd power. Whenever you have an odd numbered power, then the sign, and it's a negative, the sign is going to stay negative. So 3 times 3, or 3 to the 3rd power is 3 times 3 times 3. So that's going to be negative 27. Negative 27, that's your final answer for this. Okay, so now we have 4 over 4 to the negative 3rd. So what a negative exponent does is you take the reciprocal, whatever. If it's on the bottom, you put it up on the top. If it's on the top, you put it on the bottom, and you change the sign on the exponent to a positive. So this is going to equal 4, that number right there, times 4 to the 3rd power. All right, so that's what that equals. And that would, if you want to combine those, 4 times 4 to the 1st times 4 to the 3rd is 4 to the 4th power. And that's 4 times 4 times 4 times 4. That would be 256. All right. This one's pretty simple, but it's important that, again, you understand this principle of a negative exponent. This is going to equal 1 over 4 squared. So you take the reciprocal, 1 over this, and change the exponent to change the sign to a positive. So that's going to be 1/16. Okay, the principle here is number 3 right here. So a to the x and then raised again to the y is x times y. So you're going to come here. So it's going to be 3 to the 3 times 2, which equals 3 to the 6th. And that equals 729. Okay, this is the same as number 6. If I give you a duplicate by mistake, just go ahead and do it anyway. It's more practice. It's 3 to the 3 times 2 equals 3 to the 6th, which equals 729. All right, so this one is negative 2 to the 5th. Now, whenever you have an odd exponent, that negative sign is going to stay negative. So what you can do is just put it out here and say 2 to the 5th over y to the 5th. You can distribute that 5th power to the 2 and to the y. So that's going to equal the negative sign. 2 to the 5th is 32. And you cannot simplify y to the 5th, so you just leave it like that. That's your final answer. All right, right here. So it's x, the top is going to be x to the 5 times 3 equals x to the 15. And the bottom is going to be 3 to the 3rd. So again, you distribute this to this and then to this, which equals 27. So the answer is going to be x to the 15th over 27. That's the final answer. All right, log base 4 35, or 7 times 5, but that equals log base 4 of 35. Okay, and for this one, you use the change of base. Whenever you have some oddball base, like base 4, so log of, in this case, 4 to the 35, you can change it to any base you want. Get that on screen there, any base you want. We're always going to choose base 10, which is what your calculator does. So it's log base 10 of 35 over log base 10 of 4. So we're going to go ahead and do that. Remember, when you don't show a base, it means it's base 10, so you can just work that on your calculator. Okay, log 35 is 1.54, and log of base 4 is 0.6. And you just divide this by that, and we get 2.56. All right, keep going. All right, now condense just means you make it into a single log. So I'm going to explain what that means in case you forget on the test. So you got to put these together. So you go to your rules again. What is a plus when two logs are added like that? What does that do when you condense it? It's like this: log A plus log B equals log of A times B. So we'll go ahead and just do that. You have to be sure to put the base 4, okay? It's not base 10. And it's this times this, so it's 2 times 32. Okay, that equals log base 4 of 64. So remember what this is saying. It's saying what do you raise 4 to? What power do you raise 4 to get 64? The answer is 3, but what if that wasn't obvious to you? Then again, you can use the change of base. So you can say log 64 base 10. Now we get to change the base to what we want, which is base 10. Log base 10 4. Okay, so the log of 64 gives you 1.8 over the log of 4 gives you 0.6. When you divide those two, you get 3, and that's your answer. All right, this one over here. Now this one we can't, we can condense. This one we could actually find a value, an actual numeric value answer. Why? Because there's no x's in here, so it's only numbers. So this actually equals a number that we can determine. This equals a number we can determine. So we came up with that number, which is 3. Okay, the final answer. This one doesn't. It has variables, so you can't do anything more than condense. So again, we're going to go back to rule number 4 in this case. It says when you subtract a log from another log like that, get this cleared for you. Subtract 2 logs like that, it becomes a fraction, a ratio of A over B. So this one's pretty simple. You don't have to do much to this one. Okay, so it's going to be log, and condense means you turn it into one log, so it's this one over this one. Okay, and there's nothing else you can do. You can't solve for x at this point. It's just that. That's all you had to do. Okay, rule number 4. All right, now this is expanding. So you got a multiplication there. That means expand means you're going to have more than one log now. You could have 2. You could have some number greater than 2. All right, so let's see if I can get this thing focused a little better. There we go. It's a little better. Okay, so it's log of base b of x to the 4th times cubed root of y. So you're going to write that as log b x to the 4th plus log b of cubed root of y, and that's it. That's all you can do with it. Now, just as an additional point, remember you can always express this, a cubed root, as y to the 1/3 power. You just take the reciprocal of that. So if you had to do a cubed root on a calculator, there is no cubed root button. So what you'd have to do is change that into y to the 1/3 and then use the exponent, y raised to the exponent parenthesis 1 divided by 3, close parenthesis, and then hit equal, and that would give you how you do a cubed root or any other root other than a square root. Okay, here we go. This one is asking us to expand also, so it's going to be log b 2x, the one on top, minus log b, the one on the bottom, x minus 3. And there's nothing else you can do to that one to solve any further for x, okay? Get that on the screen. Okay, so you see how that works out. It's a minus when it's a fraction like that. Okay? Okay, now we go on to number 15. This one's a little messier than it looks. Okay, so what we're going to do here is we're going to remember the principle that when you have a log, you want to convert it to an exponential. You make the little guy big, so make a big X, and then you switch the 5 and the 32. So it's to the 5th equals 32. That's how you turn a log into an exponential. Little guy big, switch the other two. So we switch the 5 and the 32. Okay, so now some of you could look at this and say, oh, I can see it's 2 to the 5th. 2 to the 5th is 32. You're done. But what if you couldn't do that? Okay, so what we're going to do then is we're going to take the log of both sides, and we're going to remember that if you have an exponent inside of a log, you can pull it out to the front. And that is rule number 8. Okay, so you can bring this 5 out in front. That should be 32. And that's log 32. Okay, now we can divide both sides by 5. Okay, actually let's do that, and let's take the log of 32. So I'm going to move over here. So I'm going to do that first actually. I'm going to say 5 log x equals, and the log of 32 is, let's do that on your calculator, and that gives you 1.5. 1.5. Now you simply divide both sides by 5. These cancel, and you get log of x equals 0.3. That's 1.5 divided by 5. Now you simply raise everything as an exponent, make everything an exponent of 10. So the log and the 10 cancel out. You have x equals 10 raised to the 3rd power, or excuse me, yeah, 10 raised to the 3rd power, and when you do that, you get 2. So that's the answer. That's your final answer. So that one's a little messier than it looked. Okay? All right. Okay, the next one, number 16, looks similar, but it's actually an easier problem, okay? So what you're going to do is say 9 squared. You're going to make everything an exponent of 9 because your base over here is a 9. So that equals 9 raised to the log of base 9. I'm having trouble with my focus today. Base 9 of x. Okay, so these two, 9 squared is 81. And 9 log base 9, this cancels out. Okay, it inverses. So that equals x. And that's it. That's your answer. X equals 81. All right. Remember, when you want to do the inverse, you have to do it to the same base that the log is in. So it's log base 9, so you have to raise 9 raised to that power, and that will inverse. Don't use a common log. All right. Let's keep going. Okay, here we got an x and a y, and it says condense. You can't figure out either x or y if you have two variables and only one equation, so we're simply going to condense. So the first thing we're going to do is we're going to say log raised to the 2nd power. We're going to move that back up there, minus 3y. Okay, so what do you do with this? Well, the answer is nothing. You can't condense this because it doesn't have a log on this side. So that's the point of this problem. You have to have a log in front of both of them to do a condense. So this is as far as you can simplify it. Okay, and that's it. All right, let's come over here. All right, now everything is in logs here, so you can do it. So what we're going to do is we're going to change all of this to log x to the third. We're going to put the exponent up there. Log y to the fifth. Log z to the sixth. Okay, so now you're back to principles numbers 2 and 4 here. You got an addition in there and you got a subtraction in there. So you simply do this. The addition is going to be this, and the subtraction is going to be in the denominator. And I should actually change that. We're condensing it. So I'm going to put the log out in front. And that's going to be over z to the sixth. Okay, so there it is. So there's only one log, and it covers all of these, so that's your final answer. All right, keep going. Number 19. Okay, so what we do is put this back in the exponent. X squared, I just put that back up in the exponent. That's rule number 8 again. Equals log 25. Now, it should become apparent to you that you don't have to use the inverse here directly. If log of x squared equals log of 25, then it reasons that x squared equals 25. They have to be equal to each other. Okay, but if you want to use the 10 raised to the log x squared, you can do that. 10 raised to the log 25. Okay, so the log and the 10x cancel out, so you have x squared equals 25, or x equals 5. Okay, finally, on this one, we're just going to go ahead and take, whenever you have an x up there, you inverse it. You can just go ahead and use the common log. So log of 4x equals log of 15. We're using common log, base 10. The x comes out in front. We now go to the calculator and figure out what log of 4 is. And we've done that a few times, so it's 0.6 equals log of 15. And that's 1.18. Okay, divide both sides by 0.6. These cancel, so that means x is going to equal 1.96. Now we've been doing some rounding, so this may not be exact, but if you want to check your answer, plug 1.96 into there. So do 4 caret 1.96 equals, and you get 15.1. So it's close enough, given that we rounded numbers here. That's right. Okay, so again, so that takes care of that. That's how you would check that. All right, so that takes care of all of these. Study them. This is what your test is going to be on Tuesday, so be sure you know how to do these problems.